All right, today's lesson is on section 5.3, medians and altitudes of a triangle. So let's first define what a median is. The median of a triangle is the line that goes from the vertex of a triangle to the midpoint of the opposite side. So you can see here I have drawn in the vertex, and the line that goes to the opposite side of that vertex is the median. Okay? And it's at the midpoint. So we know if this is a median that I have drawn there, then I know that this segment down here is congruent to this segment right here. So just by knowing that it's a median, I know that that relationship exists. Then the next one is the centroid. And the centroid is the point of concurrency of all of the medians. So if I were to draw the median going from this vertex to the other side and this vertex to the other side, they would all meet at one point of concurrency. And that point of concurrency is called the centroid. And the centroid is 2/3 of the distance from the vertex to the midpoint of the opposite side. So if I look down here at this next example that I have this triangle ABC, and the median from vertex A is F. The median from vertex C is E, and the median from vertex B is D. And all of those points meet at point P. So now point P is the centroid, and it is 2/3 of the distance from the vertex to the midpoint of the opposite side. So if I look, AP, so this point, this distance, this line segment right here, AP, is 2/3 of the whole entire median. Then CP is 2/3 of this entire median, and BP is 2/3 of this entire median, which means then that PD is 1/3. Okay, so that's important to know because now that we're winding up our proofs, and hopefully you see that we're getting a little bit more algebraic, we're going to start looking at using these things to find distances and things like that. Okay, here's an example that I have for you. It says that C is the centroid of triangle KID, and CM is 8. So I want you to find out how much is KM, so this entire median, and how much is CK. So CM is 8. So this little piece right here is 8. That goes from the centroid to the opposite side. So this KC is 2/3 of the entire distance. So see if you can work that out and find those two distances. Okay, so that's medians. Altitude, let's define that. Altitude of a triangle is the perpendicular segment from a vertex to the opposite side, or to the line that contains the opposite side. So now, not only are we drawing essentially the same type of line, except for now it has to be perpendicular. So before with a median, it had to be the midpoint. Now we're looking at the altitude. So if you think about the word altitude, if you've ever flown on an airplane, they always come on the speaker of the airplane and they say it's now safe to turn on your electronics because we've reached our cruising altitude. And so altitude here means the same thing as it does when you're on that airplane. That is the distance from that airplane straight down to sea level. And so then if that happens to be the case, then it has to be perpendicular. Because that distance, if you drop and go straight down perpendicular to the ground, is going to be very different distance than if you were to measure out into the horizon. So altitude is always has to be perpendicular. So again, the point of concurrency of these altitudes does meet and is called the orthocenter. So we have a lot of different points of concurrency between our medians and altitudes, and what we looked at in previous sections with our angle bisectors and perpendicular bisectors and things like that. So make sure you keep all of these titles straight. So if I look here at this acute triangle, and if I look at these altitudes, they all meet right here on the inside of this triangle. If I look down here at this obtuse triangle, the triangle itself is drawn in pencil. Okay, so it's this triangle here. And if I look at the altitudes, those altitudes are on the outside of the triangle. And so that orthocenter, that place where the altitudes meet, is on the outside. So the orthocenter is on the outside of an obtuse triangle. Okay, so have these notes done for class tomorrow. We'll discuss these in depth a little bit more. We'll look at some examples together and have a great night.